These practice problems are located beneath your solving systems by elimination practice. So these are on the elimination practice. And notice that the instructions are different. It says to substitute. So with substitution, what should be coming to your mind, what comes to my mind, is something being able to get all by itself and then replace to solve for something else, right? And so when I see substitution, I think of looking for that variable that's all by itself, that's easy to get all by itself. So let's get our note card. Let's get a note card, and we will make a new one for solving systems by substitution. And the first thing I look for is a variable that is easiest to isolate. And I see a number 9. We're going to do number 9 and 10 together here. I see a number 9. The x is going to be the easiest to get all by itself, because 6x equals 24 is a one-step equation. Divide each side by 6. I get x equals 4, and that's the first value in our triplet that we will identify. And this is all of my space that I have to work with. And that was step number 1. So step number 2 is to substitute that into both equations. So we're going to substitute the isolated variable into the other equations. Now the other equations that the variable didn't come from, right? So the other equations that are not boxed. So I'll put it back into here, and I'll put it back into here. So let's see what happens. So step number 2, I put it back into the first equation. 6 times 4 equals negative 20 with the x, and I get x plus 24 equals negative 20. No, we solved for y. So this is for y, or we solved for x already, so this would be for 6y. Let's just write the equation again, and then we'll substitute here. Plus 6y equals negative 20. Subtract negative 4 from each side. 6y equals negative 24. And when we divide, we get y equals negative 4. And then if we substitute both of these, well, we'll substitute that x back in. So step number 3, we've got x equals negative 2y minus 4z plus 16. And we were going to substitute the x back in, and so we do. And then we substitute the y in, and we get negative 4 here minus 4z plus 16. And so 4 equals negative 2 times negative 4 is positive 8 minus 4z plus 16. We combine our like terms, and 8 plus 16 is 24 again. So 24, so 24 minus 4z. We subtract 24 from each side. And if negative 4z equals negative 20, then z equals positive 5. And that's the last value in the triplet of our solution. 4, negative 4, and positive 5. So let's do that again in number 10. The last step here would be to isolate and solve for all remaining variables. And I'm going to model that in another problem that's a little bit more challenging in number 10. So I see here that the easiest one to get all by itself is the one that's all by itself already. The one that's all by itself already is the x. And I'm going to take this and I'll substitute it into both equations. Let's do this in a different color. So this is number 10. Number 10. We'll do in purple. And this is all the space I have. And step number 1 is to substitute it into the first equation. So 5 times 2z minus 2 minus 7y minus 2z equals 25. And you get these kind of long equations that just take some going through order of operations to get it to reduce. So we distribute the 5 and 10z minus 10 minus 7y minus 2z equals 25. And so then we combine our like terms. We'll combine our like terms, the z's. So 8z minus 10 minus 7y equals 25. And then we'll get all of our variables on one side in standard form for that first equation. And then the second thing we will do is we will substitute it into the last equation. So negative 4 times 2z minus 2 plus 5y plus 6z equals negative 17. And if you need to do this in your journals, you can do it in your journal, in your notebook on a separate sheet of paper, because I know I write small, but as much information in one area as possible to keep it all organized. We will distribute negative 8z plus 8 plus 5y plus 6z equals negative 17. And we again combine our like terms with the z's. Negative 2z plus 8 plus 5y equals negative 17. And then the last step is to get our equation into standard form, at least somewhat, right? Because it's not in alphabetical order. But we've got all our variables on one side at least, and that makes it easier. Equals negative 25. And now we would add these two equations together that we've just found. These two equations that we've just found. So, and that's step number 3. Negative 2z plus 5y equals negative 25. And we will add it to 8z minus 7y equals 35. Now you notice that we do have opposite signs on our coefficients, but we don't have the same value of coefficient. So we have to multiply first. And we've done this before in Algebra 1. But you have to multiply these first. When I did it, I multiplied the top equation by 4 to eliminate the z, but you can eliminate the y first. That would be up to you to show how to do that by multiplying each equation by something that will get you matching coefficients, matching but opposite, equal but opposite. So I multiplied this by 4. I got negative 8z plus 20y equals negative 100. And I added it to 8z minus 7y equals 35. The z's canceled out, and I got 13y equals negative 65, so y equal to negative 5. And that's the first part of the solution that I found. And then I used that value and I substituted it in to another equation. So I thought the y value was most useful and easiest in the first equation. I substituted it into the first equation. So, and I'll just write this up here, 5x minus 7 times negative 5, now that we know y, minus 2z equals 25. So 5x plus 35 minus 2z equals 25. This is step number 4 that I'm taking here above. 5x plus 35 minus 2z equals 25. And then if we subtract 35 from each side, we get 5x minus 2z equals negative 10. And so there's a 2z, something I noticed when I solved this, and part of solving systems is looking for clues and easy ways to get to where you get all of the variables you're looking for, like a puzzle. And something I noticed in this new equation, this red equation that I just found, it has a 2z in it, and so does this equation from the very beginning. It has a 2z. And I thought to myself, well, if x equals 2z minus 2, then if I add 2 to both sides, 2z equals x plus 2. Which, why would you need to know what 2z's equal, except that we can substitute it into our equation that we found. So 5x minus 2z, which is x plus 2, equals negative 10. And now I only have one variable to solve for. So as I solve for x, now I get 5x minus x minus 2. So I have to distribute the negative to both pieces inside my parentheses, equals negative 10. And now I combine like terms. 4x minus 2 equals negative 10. And when you add 2 to both sides, 4x equals negative 8. So x equals negative 2. And that's this next part that I found in my triplet. And then z is really easy because we already have this middle equation, which is x is negative 2, and x is 2z minus 2. So we can substitute it back into this equation. Let me highlight that in green. No, not write it in green. This equation here, we can substitute it back into this one. So it is really like a puzzle, just finding all of these pieces. And so 2z equals negative 2 plus 2, which is 0. And if the whole thing equals 0, then z equals 0. And there's the last part of our triplet, which would be negative 2, negative 5, and 0. So you do the rest of the practice problems with steps, solving each system by substitution.